All right, everyone. How's everybody doing? As you already know, for this week's lab, we'll be completing the demography handout. And if you've already looked at it, you have seen that there's tons of really great, fascinating information that can be found on the handout. And we will not be going over any of it. What we will be focusing on is how to construct a survivorship curve, which if you have looked through the handout, you've already seen that that is part of your assignment. You will need to construct a survivorship curve with the data that has been provided to you. All right, so for part two of your laboratory exercise, you're going to construct a survivorship curve. This is taken straight out of your handout using this data from ages at death for men in Southwest Austin, Texas. You're going to construct a survivorship curve, plot your survivorship curve, semilog, and label the axes. And what semilog just means is that for this graph that you're going to be creating, the y-axis will utilize log transform values and the x-axis will not. So your log transform values, you're going to be using on the y-axis the natural log of s of x, and the x-axis you're going to be using age. And all this will make more sense as we go through this PowerPoint because we're going to be doing everything step by step. It should be pretty smooth for you guys to complete on your own. So your total number of values is somewhere around 430. I did not use all your values, so I would definitely double check to make sure you have the right total number of values right at the beginning, because that is going to be very important as you continue on with this exercise. So what I did was I took a random sample of 248 values out of the total 429 values, and that is what I utilized for this example. So even though I didn't use all of the values, I should give you a pretty good depiction of what you should expect to see after you complete the exercise. And actually yours should look a lot better than mine because you have an additional whatever number, close to 200 values that you'll be able to, of data that you'll be able to use as well. You can definitely create this scatter plot on Excel. It's really easy. You're going to be doing everything on Excel anyways. So if you do not know how to use R, I would not recommend using it or trying to even figure out how to do it. I would just do it on Excel. Don't waste your time. But I did mine on R, and if you do know how to use R, if you've already taken a class in the past, I did provide my code if you want to go ahead and figure out how to put your data on there with use of my code. So yeah. All right, so the first thing that I would like to hit on is how to organize your Excel sheet, because for your assignment, you are only given the ages at when these men in Southwest August, Texas had died. So you're going to have to create and format your Excel sheet yourself. So how I can go over a few steps with you on how you're going to do that. I would start off with copying your values to your Excel and labeling that column as age. So it'll be one column consisting of about 430 values underneath your age, underneath the age column. You're going to highlight that entire column, all of your values, and you're going to sort your values from small to large. So it'll be starting at 0, and then it will continue on to around, I think, like 98 is where the ages extend to. You're going to create a second column named count, which in your handout, they refer this as dx, x being age. And then after that, you will count how many of the same ages are repeated and place the count next to one of the values. And by that I mean, so if you're going through your list, right, you have everything in numerical order, 0 to 90 something. In there you might see you have 5 zeros, 5 individuals at age 0 who had died in this given location. You might have 1 at age 12, 1 at 20, 10 at age 45. So what you're going to want to do is count up how many repeated values there are. So say if you have 5 of age 0 in your count column, next to that age 0, you're going to put 5, but you're only going to put a 5 next to one of those zeros, because as you'll see later on, you're actually going to remove those duplicates. So it's not really necessary to put values next to every single value on your Excel sheet. So after you've already organized everything, you've counted how many repeated ages you have your counts next to them, you're going to go ahead and remove those duplicate values found in the age column. And how you're going to do that is in Excel, you have a data tab. You're going to click on your data tab, and within the data tab, you'll see that there is an option to remove duplicates. Once you click on that, it's going to pop up a second screen, and it'll ask you what you want to remove duplicates in. And it's very important that you want to remember to only remove duplicate values found in only the age column, right? Because you might have several ages where they only appear one time. So you might have 1 of 0, 1 of 25, and you don't want to remove all of those ones. You want to keep those, but you do want to remove those 5 zeros, those 5 15s, or 3 20s. You want to get rid of those extra values, and you only want to have one of each age value with the total count of how many times that appeared in your data set next to that value. So after your duplicates are removed, only one of the duplicate values will remain, and their count should be present in the count column adjacent to the value itself. To confirm it worked properly, take the sum of the count column, and this should equal your initial total value. So as we spoke earlier, when you copied and pasted those values, you have to double check that, I told you to double check how many values there were. So it's approximately around 429, 430 values. And after you do your count, after you remove those duplicates, you counted how many times they appeared, and you have your count column completed, that value should be the same as that initial value that you determined early on in creating your Excel sheet. All right, so after we have put all of our age values into Excel, organized them, removed our duplicates, and determined our D of X, or counts per age, you're going to next determine your S of X and its natural log. So first thing you're going to do is you're going to create a new column, and you're going to label it S of X, where S of X is the total number of individuals alive at time X. So your first value of your S of X column should be the initial value for the total number of individuals found within your data set. So like I said, you wanted to determine that initial value at the beginning, similar as previously in this video. It's probably somewhere around 430, and that's going to be your first value. And then your S of X for the next row is going to be the previous S of X minus the previous D of X. So let's say at age 0, right, your initial S of X is going to be all your individuals, because everyone at this point in time is alive. So say 430 is your initial S of X. But the number of individuals that died at age 0 or at birth was 5. So for the next row, your S of X is going to be that initial, the previous S of X, which is 430 minus the number of individuals in that count that died at age 0, or the D of X of that previous column, which is 5. So your next S of X is going to be 425, and that will continue on throughout all your age values until eventually you'll get down, and you might have one individual left in your S of X column for the very last value. And then next, what you will do is you're going to create a new column and label it natural log of S of X, and you're going to take the natural log of all the values present within your S of X column. And that's really important, because creating this natural log of the S of X, you're going to plot that on your survivorship curve, and that will make your curve actually look a lot smoother, and it's going to be a lot easier to differentiate between other curve types. All right, so here I have my example Excel sheet, right? We have everything nice and organized. We have our age column, D of X, or our count of how many individuals died at each age. We have our S of X, which is the individuals alive at time X. We have our natural log of S of X, and we have our L of X, which is our remaining proportion of individuals alive at time X. So as we go on, you see for age 0, for my data set that I used, I had 4 individuals die at age 0. But as you can see, I already removed those duplicates from my age column, so I don't have any duplicate values here. Which is why I also said it was really important that you do not remove those duplicates from your count column, because you're going to need those values in order to create that survivorship curve that we're going to be making. And for our S of x here, we have at time 0, right? We have everyone is alive. So I had all my values. I had 248 individuals within my data set. So at S of x at age 0 is going to be 248. But you can see at when we go on to age 1, I had 4 individuals who died at birth or at age 0. So I'll take the previous S of x, and I'll subtract the previous D of x from that value, and that will give you my new S of x for the next row. And you'll keep doing that down until you calculate all the S of x for all the ages present within your data set. So it's always just going to be that previous S of x minus that previous D of x. That's all you're going to have to worry about to calculate these values. And for your natural log, obviously you're going to take that natural log of this value here. So, take the natural log of 248. This is the value that I got. And on Excel, it's really easy to just, click on your cell and pull that down, copy that function for all of your S of x values, and you'll get a really nice natural log of S of x column already complete for you. And for our last column here, we have our remaining proportion. So like I mentioned previously, at time 0, right, everyone is alive, same as how I have 248 individuals out of my 248. I also have 1.0 proportion alive at time 0. So in other words, saying everyone is alive at time 0. But as you can see at age 1, I've lost 4 individuals, now at 244. So only 0.98 of my initial proportion of individuals alive at the beginning of my data set is still present. And that's really easy to determine. You can just take whatever your S of x is for that row. So for age 1, my S of x was 244. I just divide that by my total number of individuals in my data set, which is 248. And you can just take your S of x and divide it by that initial number, and that is how you're going to calculate your proportion for all your values. And now go from 1 to 0. So with these values here, you're going to create a scatter plot with the x-axis consisting of the age values from 0 to x, and per se, probably I think it's somewhere around like 98 or 99 is the maximum value that you're going to have. And the y-axis is going to be the natural log of S of x, which is going to be the natural log of your total individuals alive at time x. So like I said earlier, natural log is just done to make your survivorship curve look nice and clean. Once you're done with creating this table, you're going to copy and paste your whole table onto your assignment sheet. So you don't got to worry about making it nice and pretty. Just put your values on there and you should be good to go. All right, so lastly, you will create your scatter plot. All right, so here I have mine. Like I said, I did mine on R, but you do not have to do yours in R. It's going to be really, really simple to do in Excel. If you don't know R, that's okay. Just go ahead and use the Excel function to create your scatter plot. But what you do need to do is label both your axes. So here I have age, x in years, right? And I have my y-axis as my natural log of S of x, which it's okay for you to just put this on your y-axis. And then I gave it a title as well. So this is my title. You can title yours whatever you want as long as it's appropriate for your data set. And yeah, so if you do already use R, I would not recommend learning R just to do this one problem. You might learn it later on in your time as an undergrad, but if you do want to use it, here's my code in light blue. You'll need ggplot2 to be able to create this graph, and make sure to set your working directory, import your data, and here is the code I use to create my scatter plot. So from this, you can see that it's a really, really nice survivorship curve. Yours is going to look even better than mine because you have 200 more values or something like that, more than I do, which just means your curve is going to be really clean. And you should definitely be able to tell what type of survivorship curve this is. So I'm not going to tell you right now. I think you could figure it out. You probably already know from just looking at it. But yeah, so that is this lab exercise, part two. If you have any questions, definitely feel free to ask. Stop by my office hours. Um, and yeah, I think with this information, you should be pretty good to go ahead and complete this exercise. So, cool.